Okay, and a good morning to everyone. And that was Creedence Clearwater Revival, and that was standing, well, on the corner, correct? Down on the corner. Okay, now that's sort of a signature performance. We did Midnight Special earlier, and I don't know which is the more well-known, but Creedence Clearwater Revival, neat group. And I'm assuming again out of that 70-80 period, somewhere in there. Way 70s, late 70s? Okay, it's good stuff. I gave you a card, blank card, 3 by 5. I'd like you to turn to page 50 in the orange book, page 50, and in that, just if you don't have it with you, you're going to find formulas. So here's a typical one, as Debbie cuts to the document cam. Typical formula. Highlight a little bit. I hope that doesn't wash out on the broadcast. Now there's a set of 4 formulas. We had them for area. Remember, I'm asking you to memorize these. So we have those 4. Coming off those 4 for a moment, here's 3 more at the bottom. And then, coming off that, we go up to the top. And my apologies, I put a card on this that had ink on it, and ink got on the page. So it wasn't as dry as I thought. These are perimeter. Now we have a set of 11 of them that I want you to go ahead and memorize. Let me come back to the last group. I'm going to put these back up again. And here's what I want you to do. Out of all these 11 formulas, I want you to select the one that you're most worried about remembering. The one that you're most worried about remembering. There's the 3 for volume. Then coming off there, here's your 4 for area. So you're trying to select the formula that has you most bugged. Then the top group, ink, blot, and all. Now I could ask you a question in psychology. What do those ink blots remind you of? Okay. And I see a bird up here moving very quickly, so it's running. Okay. Anyway, what you're going to do, whatever formula you chose, I want you to write it out in the card like I did this one. So this was perimeter of a square, and I wrote the formula. Now, you don't have to write that one. It's your choice. And then on the other side, I wrote this. In this case, I put perimeter of a square. Now you choose which one you think is the hardest for you. And I want you to do the same thing in the card I just did. So let me again start at the bottom. You have to know all these, but this is just taking your choice, the hardest one that you think you'll have memorizing. Now, each of you is going to have a different formula, possibly. I can't guarantee that, but I suspect they'll be different for each one of you. If you had 11 cards, and I don't have enough cards that I give you more than one, but if you had 11 cards, you could write all 11 on these. Are we going to keep these? You're going to keep these. And the idea is that you would then simply shuffle the deck, go through, read the first part. So I would lift this card up, and it says perimeter of a square. And I would ask myself, can I write that down, or can I say it? And the perimeter is 4S. I'd write it down just to be careful. Then, once I've done that, I'd turn it over and see if I'm right. Now, I didn't used to worry about this that much, but things have changed. Now, let me give you a contrast. My education as a young child was not in the public schools, and there was a reason for it. My parents took me to a school, stood in line for quite a while trying to register, got to where I was registering, and I can remember this as a kid, and my birthday was the wrong date. And they said, you can't start school yet. Birthday was not the right time. And I remember my reaction was just what you would call devastated. I wanted to go to school. If you've watched either your own children or brothers and sisters, cousins, nephews, and so on, that excitement about going to school, really important, and drops off somewhere around the 3rd or 4th grade, and then not so exciting. But at first, really exciting. So my parents had trouble with my not being happy, being sad, crying. So they got me into a parochial school. And this happened to be a Lutheran school. Around here, your choices would be what? We have Ripon Christian, you have Modesto Christian, you have Central Catholic, you have, is it Lady of Fatima? Yeah. Has one. There's a Lutheran one up on Orangeburg, I believe it is. So there are a number of schools you can. There's what now? Okay, the Adventist Academy and series. But the point is, in public schools, the difference between church and states kept, you can't even have, in some of the schools, you couldn't even do, for a while there, the Pledge of Allegiance because of the reference to God. And so, but at a parochial school, every morning you had recitation time. So if you'd be sitting there in this school and I would say, Adrian, stand up and give me the first page of the catechism, top first 3 lines. And then you'd have to sit there, well, you wouldn't sit, you'd stand in front of everybody and you would recite every day. So you were expected to memorize nearly the entire book. And if you did that, then they wanted you to do things from Bibles. So you had to have all these things that you were supposed to do. Then I got my first job, 8 years old, delivering papers. And it was an interesting paper route. 5 different newspapers, all in the bag. I think it was San Francisco Call Bulletin, San Francisco News, San Francisco Examiner, San Francisco Chronicle, and I think they threw in the Stockton Record, or Tracy Press, one of the two, and delivered those throughout the entire city. You had to know who took what paper and which address got it, and where they wanted it delivered. The point being, I spent all my youth memorizing things. So when I ended up in graduate school, you would have a deck of cards like you have, but it would be 3 inches thick. And they would give you a test. They locked you in the room, 4 hours long. And you had to be able to answer anything on that 4-inch thick deck of cards. So I would take a deck of cards, and I would walk back and forth in the kitchen in front of the refrigerator, looking at the card, seeing what was on it, and try to answer the question, flip the card over. And you did that until you knew every card. Then when you went in to take the test, you couldn't have your cards. You'd think of the question, you'd think of the card, you'd think of your answer. The card was supposed to trigger 400 pages of reading and then dump everything you knew about the reading. Memorizing just was part of living. Now, curious, how much memorization does a typical kid do in school now? Not as much. Now Sarah tells me about when she was in school having to memorize in English. They had to memorize a play. They would have to memorize some poetry. But I don't think much of that's done. And so when I come into an algebra class, as I did this semester, and said, here are 2 pages of formulas, memorize them. And the first reaction is, how do you memorize them? So one of the techniques is what I just gave to you. Write the formula on a card, then go through the cards and do it. Now what other techniques? Anybody else have other things that work? Okay, association. Yes. I attended a seminar on how to remember things, and I don't recommend this, but I can still remember it. That's how effective it was. You're going to the shop for groceries, and you're supposed to memorize the shopping list. And say it has hamburger buns, and chips. So as you go to the store, you decide where you would put those things in a car. So you might put the potato chips in the glove compartment. I had the hamburger on the aerial, the antenna. And I had the hamburger buns stretched out over the manifold of the engine so they keep warm. you remember those things. And it was a nice way of remembering the shopping list. You may not agree, but it was effective. Other techniques, alphabetize. So if you are remembering my dear Aunt Sally, that's a mnemonic device. The letters stand for what you're supposed to remember, and you, my dear Aunt Sally, is a whole lot easier to remember than multiply, divide, add, and subtract. Well, the PE, phys ed, right? Now, the PE, parentheses and exponents. So, please excuse is our device. Formulas are that way. They help you remember what the letters stand for. So when I have LW, length, width. If I have BH, instead of a BLT, you have BH, base and height. Better than BS. So, yes, we use the letters to do a lot of different relationships. What else besides using words to help you sometimes?
I put into a song at one point. There's a song in junior high school I still remember.
Yes, okay. Remember how you remembered the alphabet? You did it to music? I have grandkids who are memorizing the alphabet. Can you hear that song in your head right now?
I have a kindergartner who sings it all the time.
Yeah, it's something that you sing in kindergarten and try to remember. Others, what other techniques? Flashcards is in essence what you're doing with 3x5 cards. Have you ever just quizzed each other? I had a student who was having trouble remembering certain things, needed to go on to mathematics, and so we made an agreement. She would come by the office any time that the office was open. She'd stick her head in the door, and I'd ask her a question. And I knew what to ask. And this was a case where multiplication problems were difficult, just couldn't remember them. So she'd stick her head in the door, I'd say 7 times 8. She'd say 56. 6 times 9, 54. Bye. And the next time she'd come in, and I'd try to keep a mental checklist of which ones to ask. It paid off. Eventually, she knew them, and then went on. Any other techniques? You ever sat and written something out 500 times? It used to be punishment in the parochial school. Write your name on the board 500 times. I will not talk. I will not talk. And you do it 500 times on the board, and then what would happen the next day? You talked. But you were supposed to, on the basis of that, not talk. So repetition. I do that when I tell my students in an algebra class, every time you write a formula or you need a formula, write it down. I learned that in a speech class. The idea that you've written a formula down 30 or 40 times, it's in your head and you don't have to memorize it. You have to find a technique. I want these formulas known for tomorrow. So tomorrow, I'm going to go ahead and give you a very short 5-minute quiz. 5 points, extra credit on your test that you will take on this unit. Tomorrow, we will spend all of our time, most of our time, on formulas. So on that, I take your total for those 5 questions and add it onto your test grade for that unit, extra credit. So you need 4 more cards. Now I see Adrian has a whole stack over here. He'll sell you a card for 5 cents a piece. Is that the going rate? He's going to give them away. Here I gave him an entrepreneurial opportunity. Okay, he might be willing to share a card here or there. But the idea is get some cards for yourself and try to memorize the formulas. So that's first thing tomorrow. Second thing tomorrow, we're going to have a quiz on 7 through 13. Okay, that was not very gentle. A quiz tomorrow on 7 through 13. That'll be a 20-minute quiz. And that will involve fractions. That's the quiz in fractions. Today, we're going to continue our work in decimals. So tomorrow, we'll spend the first part on formulas, doing problems. Then the last part we will do on a quiz on 7 through 13. Have your book ready for 7 through 13. I may or may not be able to have time to check it, but I'll try to check some and get that started. Any questions about that? Okay. One of the questions that was asked the last hour, and I left it on the board because it's something that I need to talk about, and right over my head on the screen you see math etiquette. Let's look at what we have over here on this part. There's a question of how you write things. And so this became a question, what form do I have to use? So this is a problem where I have 2L plus 2W. That is the perimeter of a rectangle. And the question, does it matter if I write it as 2L or 2XL? In algebra or pre-algebra, I would expect the top one. But here, if you want to write 2XL, meaning 2 times the length, plus 2 times the W, that's acceptable. And the same for area. You can write either LXW or just write LW. The question of things like the perimeter of a triangle. Here was the next question. On the perimeter of a triangle, does it matter if I write it, do I have to write B first, H second, and D third? B plus H plus D. And the answer is no. But it's more commonly written as base plus height plus diagonal. And so the question of math etiquette, you want to do things so that your answers are what people are familiar in seeing. So this one right here, where I have the area of a triangle, there are 2 ways that people see this, and both are acceptable. 1/2 times the base times the height, sometimes written as 1/2 BH. This is more common in algebra. B times H divided by 2, but they mean the same thing. Now, interestingly, these tell me something about you. If you write the top one, I would guess you probably haven't been in a pre-algebra or an algebra class. If you write the bottom one, that tells me you've probably had some geometry, some formal geometry, what we call measurate geometry, and that would tell me a little bit. What you communicate to the reader sometimes is important. Now this diagram I have up here, in the same way, B is used for base. It would be considered very inappropriate to use B for what? Where the height is. That would just be confusing. Bad etiquette. So the base, the height, and D for diagonal. But the reason I left everything up here, I want you to realize that we don't always reference a right triangle this way. And so what we're going to do, Debbie, is go to the right side now where we have the 3, 4, 5 and those triangles. Because one of the things I observe as I ride around my bike rides, I try to ride on a daily basis. It's very difficult now with the days getting shorter and my day getting longer to find that time that I can ride and not do it in the dark. But I ride past a lot of places where houses are being built. And most of you know a very important thing about a house. You want 90-degree angles with the wall and the floor. So if this is the floor and this is the wall, you'd like this to be what we call squared. We want a 90-degree angle. So if you have a door or a window, you'd like it to be a perfect rectangle. You don't want some oddball shape because you buy modular windows, modular doors, and you want them to fit. So this becomes rather important. So the question, how do the carpenters, or how could they? They often just use levels or what's called a plumb bob, where you just hang something and let it quit moving, and then that's vertical, and then you try to line your wall or your post so it meets parallel to that line. But here's a technique that's been used since 500 BC and even earlier. It was argued that in the Nile River Valley in Egypt, where the Nile would flood on an annual basis, that this would be done to establish property lines. So here's what you do. You come from the corner where the wall and the floor meet, and you don't have linoleum or carpet. It's very rough at this point. You just have the subflooring. You put a nail at 3 feet. Then you go up on the wall 4 feet. Put another nail. Now, you go ahead and take a not a light piece of string, but something fairly durable, and you pull this to the point where this is exactly at 5 feet here. When you do that, you're getting what we call a 90-degree angle. Now this was known at about 600 BC by Pythagoras. Now it looks like you pronounce it Pythagoras, but it's Pythagoras. And here's what was said. If you take, these are called legs. Okay, so this is a leg, this is the leg. We think of them as base and height, but they were called legs. The diagonal had a different name. It was called the hypotenuse in Greek. That's going to be interesting to do hypotenuse. Just spelling it? Just spelling hypotenuse? Okay. Hypotenuse. That's what the 5 stands for. Okay. Well, I have it on the board in a moment. So the argument was that if I take these 2 legs and square each of them, so 3 squared is 9, 4 squared is 16, that should be equal to the diagonal squared. If that's true, you have a 90-degree angle. Now here's another case just down here. This is a 5, 12, 13. This is not as useful because walls oftentimes are not 12 feet high. So you come out here 12 feet, 5 feet up, and then you have to string something 13 feet. Not as much. But notice it works. 5 squared is 25. 12 squared, that's your 12 dozen, 144. And that does come out 13 squared, which is 169. Pythagoras, although Pythagoras didn't use letters in the same way, but if you look at what Pythagoras said, you have a triangle ABC. Notice we don't use H and D. We use 3 letters of the alphabet, little a, little b, little c. But the legs are still A and B. And so what the Pythagorean theorem states, and that's what it's called, is that a squared plus b squared should equal c squared. So if you have a right triangle, that means a 90-degree angle, a right angle is what we call it. If you have a right angle in this triangle, then this will be true. If this is true, you're guaranteed you have the 90-degree angle. Now that's another formula I'd like you to know. So you have 11 in the book, and I'd like you to know this one, the 12th one, for an even dozen. This is a squared plus b squared equals c squared. And notice c is the hypotenuse. Hypotenuse, or the diagonal. So again, what we're saying is if you have a right triangle, and that's what you draw, legs a and b, diagonal c, then a squared plus b squared equals c squared. And if this is true, you have a right triangle. And again, it's very useful in the construction industry. Okay. Any questions there? Pythagorean theorem. Very good. So you can add that to your list. Now, we talk about memorizing things. If you are going into pre-algebra or algebra, these are formulas you're supposed to know. And it'll make life a lot simpler there. I came into the algebra class this semester and I asked for them to know all these formulas, draw the pictures, and label them. So I'm going to ask that of you tomorrow, that you be able to write the formula for whatever I ask. So if I say the perimeter of a square, you're going to write P equals 4S. You aren't just going to write 4S. And I'll do it verbally. It'll be a verbal quiz. So I'll say it, you write it, and you'll have 5 of them in less than 5 minutes. We'll probably try to do that in about 2.5, 3 minutes, so it'll be fast. 5 points possible. Then, one of the things you want to practice doing is drawing the shapes. I expect you to be able to draw a cylinder, a sphere, a rectangular box, a right triangle, a square, a circle. You have to be able to draw them reasonably well. Not tomorrow, but that's before the unit's done. On the unit test, I'll ask you to do the formula, the shape, substitution, and answer. So we'll talk more about that. Now, for today, we're going to look at one of the easier reviews, I think. How do you add and subtract decimals? There is one rule that you need to remember. What is that rule? You're going to add and subtract decimals. What's the one rule you need to know? Loud enough I can hear it? Yes, I just heard it. Line up the DP, the decimal point. Here's the formal title of this particular lesson, where we're going to do the addition and subtraction of decimal fractions. We might think of it just simply add and subtract decimals. You line up the DP, the decimal point. Now, one of the things that when I think of a DP, I don't think of decimal points all the time, and you may not either. You ever have a young pup at home?
Yes.
What do young pups manage to chew up?
Everything.
Just about anything and everything they want, right? So you come home and you see your best pair of shoes chewed up, and what do you say? DP. Damn pup. So you may have a different context for DP, but we're going to think of it as decimal point. Now I'm going to talk about a problem that oftentimes gets messed up. I'm going to use some space up here, and I will, in the process, first I'm going to go to the problem that's still up there, Debbie, with the one on the right side. I'm going to look at this problem because this is a problem. There are a couple of them that mess us up, and here's one that does. The way I originally wrote this problem was the 17 didn't have a decimal point in it. Now, if I want to make problems a little more demanding for you, and we're doing decimals, I don't line up the numbers for you. You're supposed to line up the decimal point. So I give it to you in a kind of pre-algebra format, and then you have to rewrite it doing what? Lining up the decimal points. Now, what must be understood, if you have a number without a decimal, the decimal's at the end. So even if you don't see that decimal point after the 17, it's there. Now, if I write this out without these digits here, let me get rid of them for a moment. I just want you to see how much different it looks as I try to get the answer. Doesn't that look harder to do? Because you're not clear what's in what column? And what I ended up doing is simply making sure that there were the same number of digits after each decimal point, and now doesn't that look easier to do? I hope visually that seems easier. Now, one of the things, do you really need this 0 here? Well, that depends on what you're studying and what you are expecting to do with numbers. So, for example, if you were in the LVN or RN program, working with the idea of going into nursing, it would be very important for you to write 1/2 as 0.5, not 0.5. And the reason for that is decimal points are hard to see sometimes. Now, I realize that as I see your work. You may not appreciate that because you don't see 100 problems done, but I'll see something like that. Now, you can just barely see that decimal point, and if you were not being real critical, you might say, it's a decimal point. But if you were being critical, you might argue it's somebody didn't erase the board well. But if I put that 0 in front, you don't usually see a 0 in front of a number unless there's what? A decimal point. Now, I have to be careful because what do we do for the year? 06 or 05, depending on the year. And there's no decimal involved there. But for the most part, you would have a decimal in front of the 0. And if you didn't put the 0 there, it would be marked wrong. So this one's optional here, but it's not a bad idea to get into. Now you just add the columns as before, and the 2 and the 5 give you the 7. There's no carry. The 1 and the 2 gives you the 3, no carry. But what must you be careful to do? Bring down that decimal point. If you don't, it's a serious error because it's going to be a very different number. Then I add here, I get a 0, carry the 1, and I get 20.375. That's pretty straightforward. doesn't usually cause much of a problem. Okay, so how do you add up decimal values? Line up the decimal point, put the zeros after, but you have to be careful. Just let me make another comment. If I write 3.25 as my answer, I'm telling the reader something. That's this first number. If I write that down, I'm telling the reader that whatever I measured, if it was in an application, is to the nearest hundredth. That's the information I'm giving you. To the nearest hundredth, this is what I had. Remember rounding off we talked about. Now, what happens if I throw this after it? What is that giving the reader? It says I measured this to what? The thousands. There's a difference there. So be cautious. Throwing zeros gives different meaning if you're measuring. As just pure numbers, putting the zeros after the last digit doesn't change anything. I want to just leave this here for a moment. Debbie, you're in camera 2 or 1 right now? 2? Okay, well just hold camera 2 there for a moment because I want that to be done. And then what I would like to do, and I'll give you a moment because I want to do something first. In a moment I'm going to ask you to go to the document cam for a particular problem, but not just yet. See if I can do this. Okay, not as good as I'd like, but that'll work. Okay, now we're going to look at a problem like this, and I'm going to have it here on the board in just a moment. Okay, now the question, as I look at this problem, and we can come whenever you're ready, I'm going to line up the decimals, right? But let me just give you this problem. Mentally do it without rewriting it. You went to the store and wanted to get something that was $1.75, but you wanted some change. So you wrote out a $15 check. What you bought was $1.75. How much did you get back? Think of how much you get back. Okay, I have different answers. Is it $13 or $14? You paid $1 for something and another 75 cents. 13, right? So we'd have $13.75, $13.25. Which is it? $13.25. Now I'd like to show you what happens if I give a problem like this. And we had, say, a placement test. So if I were writing a placement test and I wanted you to do this problem, I wouldn't expect you to do it in your head. Here's what you would do. You'd take the 15, put a decimal point after it, right? Then you put the 175 here, and this is typically, I won't see the zeros filled in. I'll just see this much. Now, what do you think the wrong answer I get is? What did you say again? Not quite. The 7.5 will get dropped down immediately, and the 1 will be taken from the 15 and get 14.75. Now think about that for a moment. Something was $1.75 and they gave you back $14.75. I think I will write a lot of checks to your store and buy a lot of whatever was $1.75 because I'm coming out ahead big time. Put the zeros in. Then I hope it's clear to you. And again, the question is, if you go ahead and do it borrowing, and one of the obvious things you can ask, could I do this with the Austrian method? Sure you can. But I'll do it the way most of you would be inclined to do this. Do you see the 25 that you're going to get here? And then the 1 from the 14 is the 13. But if I don't go through that process, you'd be amazed how many people will tell me the answer should be 14.75. Put the zeros in. I think it will help. Now, there are times that we really get trapped, and this one I'm going to give now is a rather interesting one that involves repetition. Repetition is nice in the sense I've said to memorize something, just repeat something time and time again. But at times it can sucker you into a bad decision. So let me give you just a very simple set of problems now, I've given you 3 problems in a row. Here's what I see happening on test papers when it's a placement test. I was adding, and I just kept on adding, and I completely ignored what? The minus sign. This was bogus, but it seemed reasonable at the time. Come back and look at your test, and it was asleep at the switch. We talk about Wednesdays and how Wednesdays, you sort of go through the week, you get into a Wednesday, and you just keep doing what you did Tuesday. You know you're going to do the same thing Thursday. Wednesday is that cruising day down the freeway, doing 70 and I-5. You just keep going. Now, Thursday, things change. It's the end of the week. Monday, things are different. It's the beginning of the week. This is letting a pattern trap you. Be careful, okay? Just be cautious. Now, we've been talking, and we talked yesterday about rounding, and I want to take rounding in a different way. I have on the board some numbers here, and I want you to look at them. The original problem was this, and I'll put it in context this way. The argument was that we had to buy some gutter material for the roof of a house. Now, I hope you realize what's happened to metal prices recently. What's been the case? Are you aware of what's happened to the price of metal? It's gone way up. If you buy wiring for a house, for example, the wires used to be not the big expense, the labor was. We just did some rewiring in an old farmhouse, and the price of the wire alone was $500 just for the wire. It was nearly the price of the labor. Okay, and that was just going from a kitchen where the entry came in, taking it up into the attic at that point and going across 2 rooms and setting up the wiring for an AC. So it had to be heavy-duty wiring, but about $500 just for materials. What are they having to do in construction places right now? New home construction, what are they doing? Okay, yes, the prices are going up, but what else are they having to do? Okay, sometimes they make compromises on quality of material. Are you aware that they are, for the most part, running security cameras? Fencing, locked fencing, security cameras, and security guards. Why? What's happening? People are just simply coming in and stripping out the wire in a job site and taking anything that's metal because they can sell it.
They sell copper, or they sell
Yes.
copper
Copper wiring. And so if you have a spool of copper, it's liable to disappear.
tweakers, drug
Pardon?
addicts. I'm serious.
Oh yeah, it's worth a lot of money. I made a bad judgment back in Iowa during the summer. This is a farmhouse that's been there for about 100 years. And there were a lot of old farm equipment there that was just, if you're going to have grandkids around it, you don't want there. So I made arrangements for somebody to come in and haul out all the metal. They also took anything else that wasn't nailed down. And so lost a lot more than I intended. Now, what does that have to do with rounding off? Look at my problem here. Now, this is based on $10 a foot. So we're doing rain gutters, and we're going to do it $10 a foot, running foot. And so we're going to go out and measure. So Adrian, Chris, and I are going to go out, and we're going to buy some materials, each of us working on a separate house. But you know, the houses are in certain areas would look a lot the same. So we happen to be working on the same floor plan, 3 different houses. We're each going to be putting up rain gutters in the front. And it's a 30-foot run, roughly. So Chris has the first house. He measures, and he's very, very critical. And he says, I need 30.567 feet of rain gutter. Adrian's tape measure isn't quite as accurate, so he comes up with, for his house, 30.56. I have the last house, and I say, 30.7, sloppy, get it done, and I'm not as critical. Now, if I add those numbers the way they are, I'm adding first, but my question, when I look at that, the question I have for you, how accurate can I really argue the answer is? Otherwise, I'm saying it's 91.827. But I didn't measure that carefully, neither did Adrian. So the argument is your answer is only as good as the least precise number here. Otherwise, the fewest number of digits after the decimal point dictate what I should have in the answer. So this should be rounded off to what? To the tenths. And that gives me 91.8. So at $10 a running foot, I'd pay $918. Now, if it were gold and not aluminum or some other material for the rain gutter, something a lot more expensive, at $1,000 a foot, it would be $91,800 for that rain gutter. Yeah, if it's $1,000 a foot, you'd say to me, hey, you can't be this sloppy. You're costing me. Now, notice what happens if you round off first. So the question, round off first, round off at the end. That's your choice. By the way, to do this, I just added zeros here, only to keep things easy to do the addition. Now, I'm just going to move over a little bit, and just to there, I'll be fine. Now, look how I rounded these off at the beginning before I started. The first one becomes 30.6, right? The next one still is 30.6, and mine was 30.7. Let's look at what we get now. I add here, and I get 91.9. So at $10 a foot, it only costs $1 more, and you say, so what? But what happens if it's this very expensive gutter at $1,000 a foot? The difference here is what? $100, and if I'm doing 1,000 houses, that's $100,000 I've given away just because I round off too soon. Okay? Now you're going to have a problem in your review test like this. You have to make a judgment as to how many digits you need in your answer when you're adding. Are you familiar with an old cliche about the chain is only as strong as what? The weakest link. So if you are towing a trailer and the chain's rubbing on the ground, you hear it rattling, bouncing in the ground, sending out sparks, and it gets really weak, that's where the chain's going to break. Here's your weak link. My measurement was not precise. That's the weak link. And your answer at the end should be no more precise than the weakest link, the least precise value. Precision is the number of digits after the decimal point. That's the precision you're measuring. Okay? Now I'm just going to leave that on the board. I'll walk off screen and come back now, and we're going to look at the kind of problem involved here. It's in Review Test 15. So we're going to go to Review Test 15. And it's problem number 4. So as we look at this problem, here's the fourth problem. Now looking at these numbers, you'll note there are a different number of digits after each of these decimal points, correct? So the first one has 4 digits. What was the precision there? What's the place value of the 7 in that first number? That's my question as we come back to that now. What is the place value of the 7? You can see it in the screen. 10 thousandths, correct? Okay, what is the precision of my second number? It is written to the nearest hundredth. Finally, in the last number, what is my precision here? Tenths, hundredths, thousandths. So I have 10 thousandths, hundredths, and thousandths. So what precision should I have in my final answer? Hundredths. So that's what you're going to have to be careful. And I tell you at this point to round off to what? The nearest hundredth as you look at, there I think I'm crowded in just there, Debbie, to the nearest hundredth. Now, I've given you a problem where I'm trying to trap you. Not with malice, but still, I'm interested in not getting trapped. So as we go to this problem, do you see the trap? We've talked about that. I don't want to verbalize it too much, but there's a trap there. Be careful. Then, on the problems at the top of the page, I've used language here that I'm very concerned that you know. I'm saying find the sums, and so that means you're doing addition, although it's obvious that there's plus signs between each part. But in the next problem, I don't give you the sign of operation. I've told you find the differences, and what does the word difference imply? A subtraction, and that's going to be something that you have to be careful about. Then, I mentioned to you yesterday, and you have to be very cautious here, the difference between 100 and hundredth. Now, okay, just a moment, Debbie, that I've created a skewing there I didn't like. And let's see, come on. The battle of the camera. Okay, the difference between hundredth and hundred. Be careful. You have to know which is which. So, on rounding off, I didn't spend much time today talking about rounding. We did it yesterday. But again, let's review in a moment, and I'm going to do the board with that just to finish this problem out. Let's go back to the directions here, Debbie. And then I'll go to the board with a different number. But if I look at something to the nearest 100 or hundredth, and I have a problem like this, and I take another problem like this, so I have the decimal in a very different place, right? If I round the first one off to 100, what do I get? Should be a 600, correct? Because this goes to a 6. Here's my 100 position, and I look next door. That becomes 600. Notice I put the zeros in. To the hundredth here, this is the hundredth, and I go next door, and I get 0.59 and just throw the garbage out afterwards. 5/8. I was rounding off that 8, and I should have gone to the 7. Thank you. 5/8. Boy, a DAE at the end is not a good way to finish. 0.58 versus 600, that is a contrast you have to